The biggest reason why students lost marks for me was that they didn't actually use the factor theorem, because if it says in the question you've got to use factor theorem, then you must. So the factor theorem, as it states up here in its sort of algebraic form, is that the x minus a is a factor of f of x if f of a equals 0. So in this case, we are going to be trying to do p, because that's the function of the polynomial is p of x as opposed to f of x, of minus 3. And so we're just going to put minus 3 in whenever we see an x. So minus 3 all cubed, minus 5 lots of minus 3 squared, minus 8 lots of minus 3 plus 48. Now it's important to write out this line just so that you're showing your examiner that you know what you're doing, because this gives you your first mark. And then we're just doing some squaring of negative numbers. So 3 squared is 27, and we're going to be timesing it 3 lots of the minus. So it's minus 27. Minus 3 squared is positive 9. 9 times minus 5 is minus 45. Here we've got minus times a minus, which makes a plus, so minus 3 times minus 8, which is plus 24. And then finally, we're minusing the 48 off here. Now, at this point, depending on how much more you need to do, you should be able to see that this is going to come to 0. Sorry, that one there should be a plus, shouldn't it? So I'm looking at this thinking that this minus number is 3 more or 3 smaller than this minus number. This positive number is 3 bigger than this number. So this is going to come to 0. And we know that it's going to come to 0, but if you want to, you can spend a little bit more time working this out, but that's absolutely fine. Now you must then say, therefore, x plus 3 is a factor. If you don't write that statement, you lose a mark. So it's not worth not writing, therefore x plus 3 is a factor. For part part 2, we're doing an algebraic division. Now the method in which I would encourage you to use is the reverse of the grid method. So we all learnt sort of grid method in school. So we've got this idea to reverse it. So x plus 3, and we're dividing it into this thing. So this is what should be in our grid here. So what I want is an x cubed. X times by what gives me x cubed? Well, it's going to be x squared. X squared times 3 is 3x squared. Do I want 3x squared? No, I want minus 5x squared. So I'm going to be taking away 8x squared. X times what is minus 8x squared? Well, it's going to be minus 8x. Minus 8x times x minus 8x squared. Minus 8x times by 3, minus 24x. I don't want minus 24, I want minus 8. So I'm going to be adding on 16x. This means I'm going to have to times that one by 16. 16 times 3, hopefully, since it is a factor, is correctly 48. So I can say that I can do x minus 3 times by x squared minus 8x plus 16. Okay, now that would give me 2 marks. I want 3 linear factors, so as a result I need to factorise this thing here. So double brackets, so x minus 3. Now numbers that multiply to make 16 add up to minus 8, minus 4 and minus 4 come to mind. So x minus 4 and x minus 4. And there we have my 3 linear factors for this question. Okay, continuing then into part B, says use the remainder theorem. Now the remainder theorem, very, very similar to the factor theorem in that we are going to substitute. This time we are going to be doing p of 2. Now the difference this time is that we're not expecting it to equal 0. We're expecting a remainder. But again, I'm just going to take my time just writing it out, ensuring I don't make any silly mistakes, because this should be absolute guaranteed marks when these come up. So I've got 8, I've got 2 squared, which is 4, so minus 20, I've got minus 16, and I've got plus 48. And obviously this time I know it's not going to equal 0, so I'm going to take a little bit more care over this. So the way in which I'm just going to do it, I'm just going to do the first 2, then I'm going to do bring in the next one, and finally the next one, just to make sure that I don't make any mistakes. So 8 minus 20 is minus 12, minus 16 plus 48. Minus 12 minus 16 is minus 28, plus 48. So minus 28 plus 48 is going to leave me with 20. So I'm going to say that my remainder, when the division happens, is equal to 20. Okay, so I've now used my remainder theorem and found the 20. Now I wish to express this division and form again. Now this is pretty much a repeat of part 2 of part A. So I'm going to do exactly the same method this time, but instead of having x minus 3, x plus 3, I'm going to have x minus 2 here. So I want the same thing again, so I want x cubed. So it's going to be x squared, leaves me with minus 2x squared. Do I want minus 2x squared? No, I want minus 5x squared, so I'm going to take away another 3x squared from here, leaving me minus 3x, because minus 3x times x is minus 3x squared. Multiply these two together, I get positive 6x. I want minus 8x, so I'm going to be taking away 14x more. So 6 minus 14 gives me minus 8. From here, x times what? It's minus 14. 14 times minus 2 is plus 28. Now I don't want plus 28, I want, fortunately, the correct remainder of another 20 added on as my remainder. So writing this out in full, it is the x minus 2 that I was given. It's x squared minus 3x minus 14, and it is plus 20. Now, if you want to make your examiner's life really easy, you would then write out underneath that b is minus 3, that c is minus 14, and that r is 20, just because that's exactly what they're going to be looking at in their mark scheme.